Let's begin Chapter 3, Sections 2 and 3. We're going to do these together because they fit well together. Our objective for both lessons is to learn to graph points and lines on the coordinate plane, and our essential question, how do I then make a graph to model a situation? A lot of vocabulary terms here, and we'll talk about all of them: coordinate plane, x-axis, y-axis, quadrant, x and y coordinate, and origin. Let's start with the coordinate plane. Coordinate plane is formed by two number lines, the x-axis and the y-axis. They intersect at right angles and divide the plane into four quadrants. The x-coordinate is the first number in an ordered pair. The y-coordinate is the second number in an ordered pair. And to plot an ordered pair, we begin at the origin, or the point 0, 0. It's the intersection of the x and y-axis. The x-coordinate tells how many units move left or right, and the y-coordinate tells how many units to move up or down. Let's get a visual for that. First, we have an ordered pair of 2, 3. 2 would be the x-coordinate, and 3 would be the y-coordinate. So the red number, the 2, tells us which way we're going to move, left or right. If it's positive, we move to the right. If it's negative, we move to the left. The blue number, or the y-coordinate, tells us which way to move up or down. If it's positive, we move up. If it's negative, we move down. You can relate that to the coordinate plane. The positive numbers are going to be to the right and up, negative numbers to the left and down from the origin. You can see we have what are called quadrants. They're quadrants because it's divided into four parts, and quad means four. Quadrant 1 is in the upper right-hand corner where everything is positive. Then we go to the left to quadrant number 2. Moving counterclockwise, we go to quadrant number 3 and quadrant number 4 in the bottom right. The origin is 0, 0, which is the middle of our axis. It's where the x and y axis intersect and where we begin with every graphing problem. If I wanted to put 2, 3, the ordered pair, on the graph, I would move 2 to the right from 0 and then 3 up. And I would put my point at what is called 2, 3. Another reminder, x-coordinates move left and right, y-coordinates move up and down. Give the coordinates and quadrants of each point. So we're looking for an ordered pair for each point and what quadrant it's located in. From the origin to get to point R, we would move 1 to the right and up 3. That would be 1, 3, and that's located in quadrant number 1. If it's helpful, so you don't have to think flipping back and forth, you may want to label your quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We used Roman numerals on the previous slide, but you wouldn't have to do that if regular numbers make more sense to you. Point S. From point S, we start at 0, 0. We don't go left or right at all. That means that would be a 0. And then we go down 3. So 0 units right, 3 units down is 0, negative 3. And then we see that it says no quadrant. Because S is not in quadrant 3 and not in quadrant 4, it's in the middle, it has no quadrant at all. Point T, 2 units left and 2 units up. That would be negative 2, 2, and in quadrant number 2. And point U, negative 3 to the left, and then 0 because it does not move up or down at all. And again, it's in no quadrant. Think about the fact that if there's a 0 in your ordered pair, it is not in a quadrant because 0 is neither positive nor negative, so we can't classify it. Now let's look at this from a different perspective. Let's go ahead and take our points and put them on a graph. So if I want to graph the point 3, 4, I start at 0, 0. I move 1, 2, 3 to the right, and move 1, 2, 3, 4 up, and that's where my point is located. Let's clear off our work. Okay, if I wanted to get point B on there, I would move 4 to the right from 0, 1, 2, 3, 4, and then I don't go up or down at all, so I would stop on the line for B. Okay, if I wanted to graph negative 4, 4, now I would go left 4 spots, 1, 2, 3, 4, and it's a positive 4, so I would go up 1, 2, 3, 4, and graph point C. Lastly, point D, left negative 1, down 3, put my point, and I have A, B, C, and D on the graph. Find the distance between each pair of points. We're looking for the distance between K and L. You can see that the graph they're counting by 2's as we go along. So if I want to count from K to L, I can either look at the difference between the two values, which are the x values, and take the absolute value, because distance is always positive, so we take absolute value to measure distance, and find out that they are 6 apart. Or I can simply count 2, 4, 6. If I'm looking at M and N, these are vertical, so the two numbers that are different would be 6 and negative 6. So I'm finding the difference between 6 and negative 6, taking the absolute value because it will be positive, and finding out that they are 12 apart. Let's look at analyzing graphs. Tell which graph corresponds to the situation described below. Jamie begins the race and soon feels a pain in a muscle. He is unable to complete the race. You can see on the left-hand side the y-axis is measuring runner's speed, so the height of the graph measures the speed, and time is on the horizontal axis. So if we're looking for a graph that shows a runner unable to complete the race, the only one that would make sense would be graph number 2. So if we start up at the top and work our way down, you can see that where Jamie gets injured, he quickly drops off and is unable to finish the race. Let's look at another scenario. We have same graphs, graph 1, graph 2, graph 3 on runner speed and time. Different scenario. Melissa builds up her speed during the beginning of the race. She maintains her running speed for the remainder of the race. Take a look at which options you have and think about the parts of her race. She builds up her speed, meaning her speed should be increasing, and then she maintains, meaning her speed stays the same. The only graph that makes any sense? Graph number 1. Two words we need to discuss are called continuous or discrete. Here's a graph for the situation of a car temperature over a period of time. So the time was measured 8 o'clock, 8:30, 12 o'clock, and 12:30, and the temperature was given at each of those times inside the car. You can see that at 8 o'clock it was 71 degrees, and at 8:30 it was still 71 degrees. By 12 o'clock it was up to 82, and by 12:30 it had dropped to 74. Since every value of time has a corresponding altitude, connect the points. What that really means is that because from 8 o'clock to 8:30, we could have measured a temperature at any point in time, we connect the dots. I could look at this graph and choose a different time that we didn't list, like 11 o'clock, and get an estimate of what the temperature was at that point in time. So we call this continuous. Continuous means you can connect the dots because there's always a value at any point in the graph. Let's look at a different scenario. A market sells pumpkins for $5 each. So if we were to graph this, we could get one pumpkin for $5, 2 for 10, 3 for 15, 4 for 20, and so on. Would it make sense for us to connect these dots? Well, if we connect the dots, then what we're really saying is that if I connect all the way up, then I should be able to choose any point on here. So I could choose 2.5, and I could buy 2.5 pumpkins for $12.50. Well, I don't think that's really going to happen. If I go try to buy half a pumpkin, they're probably not going to like that very much. I can't buy 1 1/3 of a pumpkin. So I only can get whole pumpkins, meaning this is a discrete graph or discrete situation. So in a discrete graph, we don't want to connect the dots because not all points make sense on the graph for the situation that we're in. Business sells t-shirts for $10 each. Think about what before we show the graph. Do you think this will be continuous or discrete? It is discrete because, again, you can't buy parts of a t-shirt in this situation. To summarize, continuous is a graph made up of connected lines or curves. Discrete is a graph made up of unconnected points. Think discrete is dots and continuous connected. That's it. We've completed 2 lessons. Make sure your notes are filled out completely. On the left-hand side, come up with some questions that could be answered from the material in your notes. Keep trying to make those questions more and more difficult. Review your notes, make sure they're highlighted, underlined, etc., and complete the summary before class.